Speak your special blessings on all the members gathered for the inaugural ceremony. Bless all our endeavors. We specially pray for all the participants. We pray and thank you, Lord, for the success of the conference. Be with us, enlighten us. All glory be yours now and forever. Amen. Coming together is the beginning. Keeping together is a progress. Working together is success. It's a pleasure to ask Ms. Hudama Abdul Latif, Head of School, School of Computer Science and Faculty of Engineering and Technology, Villa College, Mines, to deliver the welcome address. Madam, please.
Assalamu alaikum, distinguished guests, esteemed colleagues, and fellow participants. Good morning. It's give me immense pleasure to welcome you all to the second international conference on sustainable materials and renewable technologies, Smart 23. I'm truly honored to be a part of this distinguished gathering of experts and professionals from around the world who have come together to share their knowledge, expertise, and experience in the field of engineering. The theme of this conference is particularly relevant in the present times as we face the challenges of climate change and the urgent need to adopt sustainable practices. The focus on advanced materials, processing, and characterization is an essential component of sustainable engineering, as it is through the development and the use of such materials that we can make a significant progress towards achieving sustainable development goals. This conference provides an opportunity for us to come together, share our insights, and collaborate to make a positive impact on the future of our planet. I extend my heartfelt gratitude to the principal and the team of Smart 23 for their tireless effort in organizing this event. Your commitment, dedication, and hard work are truly commendable. And it is because of your effort that we are all here today. I would also like to acknowledge the contribution of our esteemed keynote speakers who have taken time out of their busy schedule to share their valuable insights and knowledge with us. The conference has been thoughtfully structured to ensure a dynamic and engaging experience for all the participants. We will begin with lots of lectures delivered by eminent personalities of international repute who will introduce the theme for the conference. As we begin this exciting journey, I encourage each one of you to take the advantage of this unique opportunity to learn, share, and connect with other experts and professionals in the field. Let us use this platform to collaborate and come up with innovative solutions to the challenges that we all face. Let us work together to promote sustainable developments in engineering and create a better future for the generations to come. To conclude my address, I extend a warm welcome to all the delegates, conference team, participants of Villa College and SM Tech, and the keynote speakers. I hope this conference will be an enriching and fulfilling experience for all of us. Thank you.
Thank you, Udama ma'am, for your warm welcome. Thank you, ma'am. Thank you again. Smart 23, the second international conference, is a platform to learn and share knowledge, work together, and expertise. Day 1 to today. Let me invite Dr. R. Nafina Abdul Munaf, Assistant Professor of Villa College, Maldives, to deliver the opening speech about the conference.
I'm Dr. Nafina Abdul Munaf. I'm very glad to give a preface about the conference. I hope you are hearing me. Smart 23, the Sustainable Materials and Advances in Renewable Technologies, is a second international conference conducted by Mother Teresa and Mother Teresa Engineering College with the collaboration of Villa College, Maldives. The objective of the conference is to bring together the leading academic scientists, researchers, and scholars to exchange and share their expectations in the aspect of smart technologies. The theme of the conference is very broad and it has more than 20 emerging areas related to the smart technologies in various engineering field in electrical, mechanical, computer science as well as all other engineering fields. So, as a convener of this conference, myself and Dr. Joe Patrick were working for the past couple of months for making it to success. We got many papers from the participants which are very relevant to the field of the conference, and then those are the ongoing projects and then research areas which is very advanced in the engineering field. Coordinators of the conference, Dr. Jacob Rubasing and Dr. Samuel, also in the team. So, on behalf of Villa College, we are very glad to work with this team. And then we learned very new things. And then in future also, these kind of collaborations will bring us more conferences and then other programs like this. I also would like to thank our chief patron, Ms. Udma Abdul Latif, head of School of Computer Science of Faculty of Engineering and Technology, and Dr. Jasper, principal of St. Mother Teresa Engineering College, for giving us a proper directions to work with this in the aspect of every areas to get this conference a successful one. So the participants from the India as well as Maldives submitted many areas like, for example, in Maldives, our students have submitted some areas like what is the challenges of implementation of smart grid in Maldives, and then some challenges related to load management side of electrical students have submitted. Also, some staff motivational aspects, some researches are also our students have submitted. So I would like to extend my gratitude to all the team of this conference and management team of St. Mother Teresa Engineering College and for giving us the collaboration and making this conference a successful one. Thank you.
Thank you, ma'am. Thank you for briefing the insights of the conference. Thank you again. With much honor, now I cordially invite Dr. Jasper Chandran, Principal, St. Mother Teresa Engineering College, to deliver the felicitation address.
Respected Dr. Udma Abdul Latif, Head of School of Computer Science of Engineering of Villa College of Engineering and Technology, Maldives, and Dr. Nafina Abdul Munaf, and the HOD of Mechanical Engineering Department, Dr. Joe Patrick, the Director of St. Mother Teresa Engineering College, Professor Dr. George Clinton, and my fellow faculty friends, my beloved students and all the participants. A very good morning to one and all present here. I am very happy to note that the Mechanical Engineering Department of St. Mother Teresa Engineering College, in association with Villa College of Engineering and Technology, is organizing a second international conference on the topic of sustainable material and advances in the renewable energy technologies. See, today the renewable energy technologies and sustainable materials plays a vital role, especially the sustainable material which has a property of this moisture resistant, which will reduce the cost of the waste disposal and which require a very less maintenance. So as you know, when a building that will be constructed by make use of the sustainable material will reduce the energy consumptions and which require a very less maintenance, so which would be run for a longer time. So on the other hand, if you see the renewable energy system, so there are the renewable energy systems are nowadays the world is in the period of transformation period. Most of the countries are converted into renewable energy technologies. They are using renewable energy technologies. So as for the renewable energy technologies, you might have known that there are various types of renewable energy systems, that is solar, wind, then geothermal, tidal. Likewise, a large number of renewable energy systems are there. So out of this, the solar and wind will have a huge contribution, about 2/3 of the different types of the renewable energy systems. So if you take the world, the researchers are made a research in the field of renewable energy system. And in 2035, it is expected that in all over the world, in all the countries, around 60% of the countries are converted into the electrical energy will be converted in the form of renewable energy systems. So out of all the countries in the world, this Denmark is the secure first place. If you take the research that Denmark in 2035, the Denmark country, the whole country will be converted into a renewable energy system, 100%. Whereas in 2050, this Denmark, they are going to deplete the fossil fuels. So, on seeing this one, I can say that the Mechanical Engineering Department of St. Mother Teresa Engineering College and Department and the Villa Engineering Colleges are organizing this conference in a suitable title, that is Sustainable Material and Advances in the Renewable Energy System. So, really, I am very happy that our college is organizing this second international conference at this moment today in association with Villa Engineering College. I hope that this conference will give an enriched experience to all the participants. And after this inauguration session, I can able to see that a lot of key speakers are going to give a keynote address in different areas of the title of the conference. So I wish this conference grand success one, and I also congratulate all the organizers of St. Mother Teresa Engineering College and Villa Engineering College for conducting this type of a wonderful conference at this moment. Wish you all the best. Thank you. Have a nice day.
Thank you, sir. Thank you for your felicitation address. Write to be understood, speak to be heard, read to grow. It is right time to release the proceedings of the conference. It's an honor to request Professor Dr. A. George Clinton, Director, St. Mother Teresa Engineering College, to release the proceedings book of the Second International Conference on Sustainable Material and Advances in Renewable Technologies. I request the professors to release the proceedings book. Participants and guests, the proceedings book will be released shortly. Kindly stay online. We will be also messaging the link for the YouTube in the chat box. The YouTube link will be listed in the chat box, and you can also view the ceremony through the YouTube link. Every day grants us opportunities to learn and share knowledge. It's a pleasure to introduce the first keynote speaker of the day, Dr. R. Nafina Abdul Munaf. Madam Dr. R. Navina Abdul Munaf has completed the undergraduate program in the branch of Electrical and Electronics Engineering and holds a master degree in Electrical and Electronics from Crescent Engineering College. She has also completed her PhD program in Anna University in Smart Grid with 15 years of teaching experience in various reputed engineering colleges and universities. Currently, she's working as the assistant professor in Villa College, Maldives. She's published many papers in Scopus, Web of Science, and UGC journal. She's also a reviewer in reputed international and national journals. She has given many keynote lectures in reputed colleges and universities and has keen interest towards patent filling and sustainability issues in the environment. She has a keen interest in interacting and educating the younger minds to inspire and empower them. We are indeed happy to have you as a keynote speaker, ma'am. The session is yours.
Thank you. Thank you for the nice introduction. I'll be joining. Are you able to hear me? Hello.
Yes, ma'am. Your screen is
My screen is clear.
the screen is visible and your voice is also audible.
Oh, thank you. So kind of you. I'm very glad to present this topic, that is smart grid concepts and challenges in India. So objective of this presentation is, first of all, we should know what is smart grid. So defining the smart grid and enablers of smart grid. So what is the need for going to smart grid? What are some activities for smart grid happening in India? This is the objective of the presentation. These are the topics we are going to see in brief. So first of all, we will see what is smarter electrical systems. So you can see in this figure, there are three different way it was mentioned. That is what is the past electrical system, present and future. So you can see in past electrical system, so there are, we have always we know there are in power system, we have generation, transmission, distribution happening. So in the past system, there is only very less communication channels, like we have a telephone for a system operator. So if any fault it happens or anything happens in the substation, we have to do any changes in the transformer things. So there should be we have to go for a call and then he may be attending it personally, right, manually. So now for the present grid is different. So we have very more number of that is control centers, that is energy dispatch centers, control centers. So you can see this dotted lines, the dashed lines are the communication channels, and then this purple color line is the electrical connection. So when we have a different communication, when we have different SCADA like concepts, when we have now we are in the recently we are using it. So we can do some communications so that we can communicate to the substation regarding the fault or any disturbances happening, or to the consumer also, consumer side also we can have a control over the SCADA stations, right? Control centers. But what about the future grid? The future grid should be a smart grid. So if it should be a smart grid, then how is electrical infrastructure and communications? So you can see the communication infrastructure for the future smart grid is more compared to the present grid, right? So the communication, when you are communication, this ICT technology, when you are collaborating with the present grid, that is nothing but a smart grid. So how it is possible? So what are all, other than the communication technologies, what are all the advanced implementing more? So it should be connected to the grid, means how it will be grid connected, that is plug-in electric vehicles or normal electrical vehicles. So if it is also included in the future smart grid, so how the communication system should work. Also the when you are coming to the residential consumers or commercial consumers or industrial consumers, so what is the demand side management they can do? So that also, if we are incorporating with it, that is called a smart grid. So smart grid is nothing but a smartening of electricity. It is an evolutionary process, not a one-time event. So it is a step-by-step process. Still we are in the commissioning stage only. Successfully implemented smart grid is still having so many gaps. So that is things we are going to see. Why? What are the challenges? Why these gaps are there for implementing such high-tech technology to the electrical grid? So what are the enablers? Why we have to go for the smart grid? So this is the world electricity demand. This is the growing electricity demand. So you can see in this, the India is the first country which have the highest electricity demand. And you see it, right? So, but the global, even compared to the global average also, it is very high. Compared to other OECD, North America, Europe or Pacific countries and Middle East countries also, the electricity demand for India is very high. So emerging economies will need to use smart grids to efficiently meet rapidly growing electricity demand. So with the available grid, when we are going that we are at the first in the population ratio also, you all know. So when we are in the growing electric demand for Indian grid, so emerging economies will need to use smart grids. So to use efficiently to meet the rapidly growing electricity demand. So it is a very key factor we have to address to go for electricity. And then now we are in the usage of electric vehicles, plug-in electric, hybrid electric vehicles. So in all the countries we have started using it, and then there are many manufacturers are there in the field. So different kind of battery technologies which was introduced, the advanced battery technology which was introduced, also the added advantage for implementing the electric vehicles with plug-in hybrid electric vehicles. Okay, so you can see this is the from 2010 to 2050. So until 2050 it will be very high usage of this passenger LDV sales. So millions per year which is given. So it is when it is improving. So we need to have a sophisticated grid which can be included. Then only we can have a when the power charged, everything we can get from the grid. Also the excess power we can also go to the grid. So in that case, so we need a smart grid when we are going for a public electric vehicle, because we are also in the state of reducing carbon dioxide emission. So only by using these kind of technologies we can go for we can achieve our sustainable development goal. So some of the SG technology areas. So smart grid technology areas, if you see in generation side, transmission side, distribution side, as well as industrial, service, and residential side. So when you are going for a generation and transmission, the smart grid technology, what we are using is a wide area monitoring and control technology. So what do you mean by wide area monitoring and control? So we have our grid is a interconnected grid. Indian grid is now is a new grid, which is an interconnected one. So previously it is not an interconnected one. We have different we have worked as a western grid, northern grid. Like that, we have a different regional grid. But now it is interconnected. So we have one grid, which is a new grid. So at this aspect, if the Indian grid system or the developed countries power grid should have a wide area monitoring and control. So wide area monitoring and control means it can easily that is fine, locate the fault at any place, and then it will heal itself. The grid will heal the fault automatically. It will be detecting the fault, and then it will be rectifying it by doing the proper controls. So for that, we need to have a monitoring properly. So wide area monitoring control is the one we can have at the device called Beza measurement unit, which we are implementing in the grid. So a single device can monitor a wide area of the grid. And then the information communication technology integrated with all the aspects of generation, transmission, distribution, industrial, as well as service and residential aspects. So that also we should have a complete integration about the concepts. Also we should consider when you are going for a ICT integration of all the things. So the data should be protected in we should have a very secure data. And then the cyber security also a promising one, what we have to use when you are going to implement the complete smart grid for any nation. Also the renewable and distributed generation integration. So renewable energy sources we all know. So we are having many renewable energy sources, and then we are practicing also, we are using it. Solar is now used in many places, and then on grid and off the grid we are using many renewable energy sources and hybrid energy sources. So for the DG also, we have a many integration of renewable and distributed energy sources, means then it will be a very good grid which has smart technologies adapted to it. And then in transmission, so when you're talking about transmission, at present we have technologies like high voltage direct current transmission, flexible AC transmissions, power flow controllers, like so many things. So added to it, if we have a superconducting if we are working towards it, then we can say our transmission grid is completely smart. And then in distribution side, so in distribution side, the demand side management concepts are now in the research. So the demand side management concepts will make the consumers to be having an attractive electricity bill, and they will have a satisfaction towards their usage of their power, and also they will have a communication with all the details about from the substation for even any power cut or anything like blackouts or anything can be easily informed to the distribution side consumers. Also they can do load management on their own if it is implemented with the proper technologies. And then advanced metering infrastructure. So we all know now we are using smart meters. So smart meters, we have all the communication interfaces also connected to us a smart meter. So when we are using a smart meter, so it has normally we are using energy meter. So it has some advanced technology. So it will have the demand side management as well, and then that is factors which is calculated as a load curve, load duration curve, like things, forecasting things. Everything can be done easily using a smart meter, and then which can be easily the that is from consumer
This is
side,
just an
they
introduction.
can get all the
Technology is
informations
already been
regarding
shared.
their
So let's forward
usage of
to the
power.
next slides.
And then this
What I want to
electric
share
vehicle
is before
charging
I start,
infrastructure.
I would say like
So
technology has solutions
we
for
have
every distance.
electric
So
vehicles, means we should have many electric vehicle charging infrastructures. So then only it can be easily implemented. So what are the way we can provide more services for charging infrastructure? In that way, we have to deal the things. And then customer side systems, as I have told you, demand side how we can do management. So in customer side also we are going to have some management, because previously we are having we are now in using we getting power from government sector, right? Some private sectors also there. So in future, the customer will have will be like a prepaid customers. Like we have a prepaid system, right? We can select the which service provider we want. We can select we want Vodafone or Airtel. Likewise, we can also select the power production companies which is providing a very less cost aspect. So like that also we are going to in future we are going to have a practice like that in that aspect. So a customer is eligible to select his power provider, his service provider, who is going to give a service with a very less cost and it's a reliable one, like that. So they have a deciding authorities. When we are going for the advanced metering infrastructure and the communication technologies enabled with the smart grids, so all these things are possible. So that is going to be an unbundled network, that is a restructured power network. So which is the very vast advanced technologies adapted area, and that is going to be a successful one for the reduction of electricity, that is power consumption also. So that way we are going to have the sustainable way we are going to use the power. Some of the technology area for smart grid are wide area measurement and control. And in India, what in normally in the global, how these areas are in the maturity level. So when you say wide area monitoring and control, so it is just in the developing level, but it is in a fast developing level. And the information and communication technology integration, we have achieved it. And then renewable and in distributed generation integration also in the developing state. Transmission enhancement applications. So we have adapted some kind of transmission enhancement applications, but still high temperature superconducting technology is still in the developing stage. So distribution side management, so we are in the development stage only. Advanced metering infrastructure. Yes, advanced metering infrastructure is mature because it is adopted in so many places and tested, it is working successfully. So electric vehicle charging infrastructure is also a fast developing area, and customer side system is also a fast developing area. So when we consider all these enablers in the mature state, we can say this is our entire grid is a smart grid. So this is a simple diagram of a phasor measurement unit, what I have mentioned you for wide area measurements. So if we are installing this device, it's nothing but it is which is, we can say, the filters, oscillators, like high-end electronic and communication technology adapted to the